So this section is 7.3, which is linear inequalities in two variables. So we are going to kind of think of this almost as just graphing lines, but we just have a couple extra things that we have to pay careful attention to. So we're going to go ahead and go right into graphing linear inequalities. So the first thing that you have to do, step one, is to put equation in slope-intercept form. And you don't have to do that. You could graph it from standard form, but most of us seem to feel comfortable in slope-intercept form. So remember, to do that, you want to basically isolate y. Step two is to graph the points. Notice I said points and I didn't say to graph the line. So when you do this, you are going to be ignoring the inequality sign completely. Okay, step three is to decide what type of line you are going to draw. So for example, if it's less than or equal to or greater than or equal to, this will be a solid line, meaning that you would connect it. But if it is less than or greater than, this would be a dashed line or a dotted line. And then lastly, you want to shade the solution. So the major difference between an equation and an inequality is with equations, we have like a set answer, right? X equals 3. But with inequalities, it's going to be x is greater than 3, for example. So that means that there's an infinite amount of answers. So in order to account for that, we have to shade to show all of the possible answers instead of just doing the line. Okay. So we are going to go ahead and get started with this first example. So we need to solve for y to put this in slope-intercept form. So we're trying to get this guy by itself, so we're able to graph this. So the first step would be to subtract 3x from both sides. So we would get 5y is greater than or equal to negative 3x plus 30. The next step, and actually last step in getting this in slope-intercept form, is dividing each part by y. So we would then have y is greater than or equal to, this becomes negative 3/5 x plus 6. Okay, so like I said, we're going to ignore the inequality sign. So we put the equation in slope-intercept form. We're going to go ahead and graph the points using our knowledge of how we graph in slope-intercept form. So you're going to start at 6 since that is our y-intercept. So we're going to go ahead and put a dot at 6. And from there, you're going to use your slope to find the next point. So we have to go down 3 because it's negative and then over 5 to the right. So that's a negative 3 and a positive 5. So we did that. Next thing is, well, what type of line is this? Based on the inequality sign, because it is greater than or equal to, because that equal to part, we will make this a solid line. So you're going to go ahead and graph this. It is a solid line. So lastly, we have to do our shading. Now, if you look at the equation, it says y is greater than. So you want to shade everything greater than the line, which would be above the line. So that means that obviously for this inequality, anything on the line makes the inequality true. So any point on the line, and then any point above the line also makes the inequality true. But if I have a point over here, that doesn't make the inequality true. A point even right next to the line, that doesn't make the inequality true. So it has to be on the line or above the line. Okay, we're going to go ahead and try another example. So for this one, we have 21 minus 3y is greater than 9x. So the first thing that we want to do, like last time, is put this in slope-intercept form. So we want to try and solve for that y. So we're going to go ahead and subtract 21. So we get negative 3y is greater than 9x minus 21. So the next step is to divide every part by -3. So when we do that on the left side of the inequality, we just get y. Now keep in mind, when we divide by a negative with an inequality, we have to flip the sign. So we have to make sure to remember that. And then 9 divided by -3 is -3x. And -21 divided by -3 is +7. So we'll first start off with plotting our y-intercept. So our y-intercept is at 7. So we're going to go ahead and put a dot at 7. And then from there, we're going to go down 3 over 1. Down 3 over 1. Next step is, well, what type of line is this? Because it's a less than and does not have an equal to sign under, we are going to do a dashed line. So the dashed line means that the points that are on the line are actually not true. It does not make the inequality true. The only points that do are points that are less than based on that sign. So we want to shade everything that's less than. So anything that I just shaded makes the inequality true. So a point over here is not true. Over here is not true. Here is true, okay? And then again, anything on the line would not be true because it is a dashed line. Okay, lastly, we are going to be modeling with linear inequalities. So we have a problem. Ryan can spend $1,000 on his party. Pizzas cost $10 and ice cream cost $5. Okay, so I'm going to go ahead and make x equal pizza and y equal ice cream. Okay, so I know that it is $10 per pizza plus $5 per ice cream, and he can spend $1,000. So I know something will be either equal to, less than, so we have to figure that out. So basically this is saying the amount that he spends, which is on the left, has to be less than or equal to $1,000. The reason it's less than or equal to, he can spend $1,000, but he could also spend less. He cannot spend more. It doesn't say anything about him spending exactly $1,000. So we can't actually solve this, right? Because we don't have one exact answer. There's going to be several different options of how Ryan can divide up the ice cream and pizzas. So what we can do is we can graph these options, and how we're going to do that is by graphing the intercepts. So you're going to kind of just treat it like an equation. So to find the x-intercept, remember you make y 0. So it's really looking like this. So then it's just 10x equals 1,000. And we divide by 10. So x equals 100. Okay, so that means that he can spend, or he can buy 100 pizzas if he buys 0 ice creams. Okay, now we're going to do the same thing for the y-intercept. For the y-intercept, we make x 0. So that would be 10 times 0 plus 5y equals 1,000. So that turns into nothing. So we have 5y is equal to 1,000, and then we can divide by 5. So y is equal to 20. So in other words, if he buys no pizzas, or sorry, 200. If he buys 0 pizzas, he could buy 200 ice creams. So now how do we graph this? Well, because it's an equal to sign, we would do a solid line. And basically anything in here, because it's less than, we could use. So anything in that shaded area he could buy because that would be under $1,000.